Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, everybody? So, today, inshallah, we're going to work in sketching curves. So, basically, guys, we finish in the school the first topic of sketching curves. The rules of transformations. So, basically, we have three different types of transformations. To just remind you, we have translation, we have reflection, and we have stretch. Simply, translation, we can state that easily from the function by adding and subtracting, so plus and minus representing translation. Two different types of translation, we have vertical and horizontal, upwards, downwards, horizontal, right and left, so it's based on the sign. Reflection, you have to change the sign only to negative. We have two types of reflection, about x-axis and about y-axis. And stretch, we have horizontally and vertically, or we can say it another way, on the y direction or in the x direction, or we can say it another way, parallel to the y-axis and parallel to x-axis. Today, inshallah, we're going to work in sketching curves. This is the second topic on chapter 7, which is 7.3. Specifically today, we're going to apply these rules in different types of curves. Today, we're going to talk about the reciprocal curve. So just to remind you about the reciprocal curve, the reciprocal curve. So reciprocal curve, which has this shape, y-axis and the x-axis, and the equation of the reciprocal function is 1 over x. As you see, we called y-axis and the x-axis to this curve as the asymptote line. So x-axis and y-axis are asymptote. So what do you mean by the word asymptote? So these two lines, or these two axes, are representing asymptotes. What is the asymptote? Asymptote is the straight line which never intersect the curve. Okay. So as you see, y-axis is very close to the first curve, or the first part of the 1 over x, and the same thing for the other part of the curve. So we can call the y-axis as asymptote and the x-axis as well, because it's very close to the curve, but they never meet or intersect each other. So you know that x-axis has the equation of y equals to 0 and y-axis x equal to 0. So whenever they ask you in the question to state the equation of the asymptotes, you have to write x equals to 0 and y equals to 0, or you can write x-axis and y-axis, but we never depend onto these two words, because sometimes the straight lines are not equal to 0 and like y-axis and the x-axis. So we can say y equals to 1, x equals to 3, so we can call them as axes. So x and the y-axis only in this case, in case of x equal to 0 and y equal to 0. Let's take an example from exercise 7b. From the textbook, page 121. Yes, this question asks you to sketch the curve of y equals 1 over x, that we did it here, and on the same axis, do the curve of 1 over x plus 2 when x is not equal to 0, and the other curve is 1 over x minus 1 when the x is not equal to 1. And the question asks you as well to state the equations of any asymptotes. Good. If you want to sketch any curve easily, you have to do y-intercept and x-intercept. I know we can do this sketch without doing that, because we know simply in the first function of the first equation we have vertical translation, so we have to move the curve only upwards 2 units, because that too representing vertical translation by the vector 0, 2. If you have it 1 over x minus 2, then it's translation by 0 and negative 2, which is downwards. In this equation with this curve, you have 1 over x minus 1, which is horizontal translation to the right because it has minus, and positive 1 is to the left. Okay? So we have to find now the x-intercept and y-intercept. Now let's find the y-intercept and the x-intercept. So y-intercept using x is equal to 0. So we're going to use that in the first equation. So when you do 1 over 0, you couldn't do that because you couldn't divide it by 0. It's undefined. So for x equal to 0, y has no value. And then to find the x-intercept, we're supposed to use y equal to 0. So if you replace y as 0, 0 equals 1 over x plus 2. Move 2 to the other side with a negative sign. Then you have negative 2 equals 1 over x. Using cross-multiplying or interchanging the terms, you can write x equals to negative 1 over 2. So the intersection of the x-axis is negative 1 over 2. How are we going to do that? Easily, we're going to draw the y-axis, x-axis. I'll show you first the curve 1 over x. So this is 1 over x. This is the basic curve that we did it before. Now imagine that we're going to move the curve upwards 2 units. So this curve will go away from the x-axis, and this curve will cross the x-axis at this value of the x is equal to negative half. Okay, so this will be the curve, and this is the other curve after the translation. So this curve is y equals 1 over x plus 2, and this curve is 1 over x. So guys, basically these two curves are representing the same function, same equation, 1 over x. This intersection point is negative half. Okay, so the question asks you to state the asymptote. Now imagine that the asymptote has to be the same value that you have in the equation. So see, this is 1 over x plus 2. So the asymptote has to be y equals to 2, because this curve will move upwards 2 units. I mean the x-axis itself. Now the asymptote, the new asymptote is here, and this point is 2. So we have two asymptotes. Asymptotes are y equals to 2, and the y-axis itself is still the second asymptote, y-axis, or you can write x equals to 0. So we have two asymptotes now. Okay, now the other curve b, let's find y-intercept and x-intercept. Remember, the equation is y equals 1 over x minus 1. This is the equation of the curve. Fine. We're going to find y-intercept. So replacing x as 0. So y equals to 1 over 0 minus 1, which is negative 1. So y equals to negative 1. Then x-intercept, use y as 0. So 0 equals 1 over x minus 1. Using cross-multiplying, x will cancel. Imagine that the denominator, the whole denominator, is multiplying 0. So it's cancelled. So no x value. Or you can write x has no value. So you have only one intersection point. Here's the curve, easily, y-axis, and the x-axis. The equation of the curve, remember, is y equals 1 over x minus 1. Based on the rules of transformations, this is translation, horizontal translation to the right, 1 unit to the right. So this is the basic curve. Y equals 1 over x. Yeah, so imagine that you have to move these two curves to the right. So this curve will be away from the y-axis, and this curve will passes through the y-axis at negative 1. So this is the curve. This is negative 1, and this curve is going away now. Now, the asymptote is x equals to 1, okay? Because you move the curve 1 unit. Okay, it was 0, right? So you have to move it 1 unit to the right. So this is the first asymptote, and the x-axis, which is y equals to 0. So asymptotes, x equals to 1 and y equals to 0, or you can write x-axis. Now, after you see these two questions, I'll give you a question to do by yourself, an exercise. So sketch y equals 1 over x, and on the same axis sketch the curve 1 over x minus 3 when the x is not equal to 0, and y equals to 1 over x plus 2 when the x is not equal to negative 2. State any asymptotes. So you can do this question by yourself. Here we go again, guys. We're going to do question number 4 on the textbook. Question number 4 into page 22. The question asks you to copy the sketch, this sketch. As you see, this is a curve or a function which has 3 points: point O, the origin point; point B, which has the coordinates of 4 and 0. They give you only 4. And point A, which has the coordinates of 2 and 3. What are they required in this question? It's required to sketch on the same axis two functions. Sketch y equals g of negative x and y equals negative g of x. So basically these two functions, or these two curves, are the reflection curves. So this curve is g equal to negative x, which is reflection about y-axis, and this curve is reflection about x-axis. This is y, this is x. Okay, so on the same axis, so we're going to draw the curve one more time. This is y-axis. These are the main points for O and point A, 2 and 3. Point B and point O. Point O will never change at all because the reflection of the origin point will give you all the time will be the same point. So origin doesn't change at all. Now let's do reflection about x-axis first, which is this curve. Y equals negative g of x. This point stays the same. Point A, let's call it as A dash, will have the coordinates 2 and negative 3. Because you just reflect the curve about the x-axis, you have to change the sign of the y-axis. And point B doesn't change at all. So this is the curve. So this curve is y equals negative g of x. If you reflect this curve about the y-axis, now you'll change the sign of the x coordinate. The y stays the same, and you're going to change as well the point B. See, point B doesn't change because if you want to change the sign of the y coordinate, so you'll give 0, and 0 will give you the same thing, 0. Okay, this is for negative g of x. Now, origin point stays the same. Point A, let's call it A double dash. This is the image of point A about the y-axis. Has the coordinates negative 2 and 3. And point B, B double dash, negative 4 and 0. So this curve is y equals g of negative x, reflection about y-axis. Now we're going to try to do question number 5. Question 5 on the same textbook by yourself. You have to apply the rules, but this question asks you to do reflection about x-axis and translation, and stretch. So 2 times, you have both types of reflection, 1 type of translation and 1 type of stretch. What you're supposed to do in the stretch part, so when you want to do y equals f of 2x. For example, if we have the point on the basic curve as 2 and 3, and you want to find the stretch, or the image of this point after the stretch. So basically this is stretch. Let's write the type stretch on x direction by a scale factor of half. If the 2 is outside, then the scale factor is 2, and you're supposed to write on the y direction, not on the x direction. Anyway, the coordinates of this point, see, you're going to multiply the x by 2. Okay, so see, y equals to 2 by 2, which is 4 and 3, because the change will be on the x coordinate. So 4 and 3. This is for f of 2x. And you can do the question by yourself. One more thing, guys, you have to try to do question number 6 as well. See, question number 6. The graph shows the sketch of y equals g of f of x. So you're going to do this question by yourself. Thank you.